Please welcome to the dimensions of physics. In this session, we are going to discussing about the second case, which is in doppler effect. That is, while observer is moving, when the source is stationary. For that, again, we are considering an observer here, O, and the source is here, S, whose velocity is equals to Vs is equals to 0. That means the source is in a stationary position. Okay. Here when time is t is equals to t naught, and if suppose this source and it's a crust and it travels in the medium of the A towards the observer, he knows that. Okay, it is traveling in the medium of the A towards the observer. At the same time, this observer is moving towards the source. Okay, when t is equals to t1 time, when t is equals to t1 time, while the observer takes the O1 position, this crest reaches to the observer at t is equals to t1 time. If suppose the distance between this source and observer while he reaches the first crest is suppose L. Okay, from this we can get the T1. T1 is equals to, we know the distance by velocity. Distance is L here, the velocity what? Here we have to make note that the velocity of the crest reaches to the observer will be increasing. How? When this crest reaches to the observer, at the same time observer is moving towards the source. So the resultant velocity will be Vr is equals to the medium of the A, that is the crest travels in the medium V plus the observer's velocity also. The resultant velocity we have to take here. For that, T1 is equals to L by Vr. This is the equation 1. From this, again, when t is equals to t2 time, when t is equals to t2 time, if suppose again this source and it's a crest and it travels towards the observer and observer is moving towards the source, when t is equals to t1, t2 time, this crest, the second crest, reaches to the observer and this observer reaches to the O2 position. Then what is the time it taken this source, crest reaches to the observer? What is the time taken for this? Taken T2 is equals to T naught. In previous class we have discussed. In every successive crest, the time taken for, we call it T naught. That is time period. From here to here, we know that it takes the T naught time, because at the O1 position, the observer receives first crest. At the O2 position, the observer receives second crest. So that the interval between these two crests, we call it a time period, T naught. And the distance from O1 to O2, we can get that T naught into V naught, whose velocity, observer velocity here, VO, not V naught, VO. Okay, from this T naught plus the crest T2 is equals to, here we are counting the time T2 when the second crest reaches to the observer. Okay, for that, from the time taken to observer taken from O1 position to O2 is equals to T naught, and this crest reaches to the O2 position. We have to find out. For that, we can get the distance from S to O2 position. For that, we know that the total distance, initial distance minus the distance it travelled from O1 to O2. Okay, L minus V naught T naught by the resultant velocity. The resultant velocity, we know that V is equals to V or is equals to V plus V naught. this is the time taken for the second crest reaches to the observer. Then what is the third crest? While third crest reaches to the observer, what is the time taken? Again we have to count. T is equals to T naught, T3 time. T3 time. What is the time it taken? While it is O3 position, observer is O2, O3 position. T3 is equals to, from here to here we know that T naught, from O2 to O3 T naught, plus the crest reaches to the time it taken to reaches to the observer at O3 position. Okay, L minus O1 to O2 V naught T naught minus O2 3 O3 it travel V naught T naught by the resultant velocity VR. From this we can get 2 3 is equal to 2 T naught plus L minus 2 V naught T naught by V or. Okay. From this we can get the when the n plus 1 crest reaches to the observer, what is the time taken? For that T n plus 1 is equals to n T naught plus L minus n V naught T naught by V or. Okay, this is the time taken for the n plus 1 crest reaches to the observer. Then what is the time interval to taken for the n plus 1 crest from initial crest? For that the time interval we are going to finding out Tn plus 1 minus T1. Okay, Tn plus 1 minus T1 is equals to n T naught plus L minus n V naught T naught by V R minus T1 here L by V R. Let us simplify all these. N T naught plus L by V R minus n V naught T naught by V R minus L by V R. Cancel L by V R, L by V R and simplify it. N T naught minus n V naught T naught by V R. From this it is the time taken for the n crest. Tn is equals to n T naught minus n V naught T naught by V R. Okay, from this we can get what is this is the time taken for the n crest reaches to the observer. Then what is the time taken for the 1 crest reaches to the observer? That is capital T. We are denoting with the capital T. T is equals to n T naught minus V naught T naught by V or. Okay, when the single crest reaches to the observer, we can divide with the n crest. Cancel n by n. T is equals to T naught minus V naught T naught by V R. From this T is equals to T naught into 1 minus V naught by V R. Okay. From this we can get the frequency of the wave. No? For that 1 by F is equals to 1 by F naught minus into 1 minus V naught by V R. Let us simplify all this. F naught is equals F is equals to F naught is equals to 1 minus V naught by V R. From this F is equals to F naught into 1 minus V naught by V R inverse 1. Let us apply binomial theorem for this. We can get F is equals to F naught into 1 minus 1 plus, if we apply the binomial theorem, in last class we have seen that V naught by V or. Okay, we can get the formula for this. From this we can get F is equals to F naught 1 plus, in the place of the resultant velocity of the crest we know that V naught by V naught plus V. Okay, when the we know that the medium of the air is more much more bigger than this velocity of the observer. Okay, the velocity of the medium v is equal, we know that 345 meter per 343 meter per second. Okay, it is comparatively much more bigger than the v naught. V is much more bigger than the v observer. Observer here, we know that we can calculate the vehicle's speed of the vehicle with the kilometer per hours. No, it is only the velocity of the medium here is we are constantly 43 meter per second only. So it is much bigger than the O observer's velocity, so that we can make it is very negligible comparatively v, so that we can neglect v naught here. So from this we can get f is equals to f naught into 1 plus v naught by v. Comparatively, this observer's velocity is much lesser than the velocity of the medium, so that we are not taking this. For this, we can get the general formula for the frequency of the frequency of the wave when it is the source is moving, when the source is the observer is moving, when source is stationary. Okay, thank you.